Hi everyone, welcome to the online lecture series of the course EE204 Digital Electronics and Logic Design. Module 4 Sequential Circuits and Asynchronous Counters. Today we are going to study about the synchronous and asynchronous inputs of flip-flops. Inputs of a flip-flop can be classified into two, synchronous and asynchronous inputs. Synchronous inputs are those inputs which will change the output of a flip-flop upon obtaining a triggering clock signal. They work in conjunction with the clock signal, that is, the changes in the synchronous input signal cannot make corresponding changes in the output if proper clock signal is not obtained. Asynchronous inputs are those inputs which will change the flip-flop output instantaneously and independently of the synchronous inputs and the clock signal. They are used to set the flip-flop to high state or to reset the flip-flop to low state, irrespective of other input conditions, and hence they are called as override inputs. The asynchronous inputs are preset and clear, denoted by PRE and CLR. Asynchronous inputs are available in flip-flops in two types, active high and active low. Active high inputs have their normal resting values as logic low, and the particular function is done upon obtaining a logic high value. Similarly, active low inputs have their normal resting values as logic high, and the particular function is done upon obtaining a logic low value. Active low input is denoted in the flip-flop symbol with the help of bubbles at the input, and the signals are represented as their complements. The functioning of flip-flop with active high asynchronous inputs are as follows. For the values of preset and clear both 0, the flip-flop output will be according to the inputs, that is clocked operation. When clear is high, flip-flop output resets. When preset is high, flip-flop output sets. Both clear and preset must not be provided with logic high because it makes the flip-flop unable to decide whether to set or reset its outputs. Next, the concept is explained with the help of simulation. In the simulation, logic high signals are represented with small red squares and logic low signals are represented with small blue squares. Consider a negative edge triggered JK flip-flop with active low asynchronous inputs. The synchronous inputs J and K and the synchronous inputs preset and clear are provided with logic values, and the clock is provided to the flip-flop. Since J and K are both at logic high, the output of the flip-flop will be in the toggle mode. As you can see in the simulation, the LED changes its states alternatively. Now, to make the flip-flop output set, you have to change the preset value to 0, which makes the flip-flop always in the high state, irrespective of J and K inputs. To make the flip-flop always in the reset mode, we have to make the clear input to logic low. This will make the flip-flop output always in the reset mode, irrespective of the J and K inputs. Now, consider a positive edge triggered D flip-flop with active low asynchronous inputs. The synchronous input D and the asynchronous input preset and clear are provided with logic values 1 or 0, and the flip-flop is provided with a clock. Since it's a data flip-flop or D flip-flop, the output will be according to the synchronous input D. As we have given D input as 0, correspondingly the output is also 0. To make the flip-flop output to 1, we have to change the preset value to logic low. So irrespective of the D input, the flip-flop output will be always in the set condition. Now change the synchronous input D to 1. So during the next clock pulse, the flip-flop output changes to 1. In order to make the flip-flop output always in the reset mode or always in the logic low, make the clear input to 0. This will make the flip-flop output to reset condition irrespective of the data input. With this simulation and the basic explanation, hope you are familiarized with the concept of synchronous and asynchronous inputs of the flip-flop.